we do not always encounter problems that match the definition of the derivative in its simplest form. Sometimes, the expression may look a little different. In those cases, we need to be able to adjust or rewrite the problem so that it fits the definition of the derivative. Let's see how this works. We know the usual definition of the derivative at a point A is the limit as h approaches 0 of f of a plus h minus f of a all over h. Now suppose we look at the more general expression, the limit as h approaches 0 of f of a plus kh minus f of a divided by h. We can factor out the constant k and rewrite this as k times f of a plus kdh minus f of a divided by kh. If we let u equal kh, then as h approaches 0, u also approaches 0. So the limit becomes k times the limit as u approaches 0 of f of a plus u minus f of a divided by u. But that is exactly the definition of f prime of a. Therefore, this general form simplifies to k times f prime of a. This shows that even if a problem does not initially look like the standard derivative definition, we can always rewrite it so that it connects back to the definition. Now let's return to our problem. We are given the function f of x equals x cubed plus x squared minus 3x. We want to evaluate the limit as h approaches 0 of f of 3, h minus f of 0, divided by h. This expression is a variation of the derivative definition. Notice that f of 3h minus f of 0 divided by h can be rewritten as 3 times f of 3h minus f of 0 divided by 3h. If we let k equal 3h, then as h approaches 0, k also approaches 0. So the limit becomes 3 times the limit as k approaches 0 of f of k minus f of 0 divided by k. That is exactly 3 times f prime of 0. Now let's compute the derivative of f. The derivative of x cubed is 3x squared. The derivative of x squared is 2x. And the derivative of negative 3x is negative 3. So the derivative is f prime of x equals 3x squared plus 2x minus 3. Now evaluate this at x equals 0. F prime of 0 equals 3 times 0 squared plus 2 times 0 minus 3, which simplifies to negative 3. Therefore, 3 times f prime of 0 equals 3 times negative 3, which is negative 9. So the value of the original limit is negative 9.